Yeah, so hi everyone. My name is Julia Faile, and I'm a senior majoring in environmental science with a focus in energy systems. So throughout the semester, I interned with a company called Emergy, and Emergy is a nonprofit cooperative that works with local solar farms to connect its members to solar energy. So basically how it works is you would fill out a form on the Emergy website, and this form asks for your general information along with your most recent monthly utility bill. And the utility bill allows them to use your usage for calculations to make you a personalized plan. So within 24 hours, Emergy gets back to you with a personalized plan showing you how much it would cost to switch to Emergy. And throughout the semester, my mentor was Eric. He is the founder of Emergy, and he also went to UNC and studied environmental science. So my position was called Community Solar Development Intern, and my main roles throughout the semester were to conduct life cycle calculations and analysis in Excel and Google Sheets. So my first task was to complete a life cycle calculation. And as you can see here, this is an example of a plan that you would get sent from Emergy. And on the right side, you can see there are CO2 equivalents, and they show the equivalent CO2 impact you save when going solar, but in terms of trees planted or people eating a plant-based diet. And my task was to calculate the CO2 equivalent in terms of pounds of food composted. So I had to do some research to find the appropriate data, and then I did some calculations, and I found that 30,189 pounds of food would need to be composted to divert the same amount of CO2 as going solar. And I really enjoyed this task because it was pretty cool to see the CO2 impact in terms of something that is easier to put into perspective. Sorry. Um, so my second project and what I was working on up until the end of my internship focused on the rate engine that Emergy uses to calculate the cost of energy on a monthly basis. So my task was to incorporate demand charges into the rate engine. So I started out with research on all of the different rate structures and then implemented them into the spreadsheet. So after finishing the task, the spreadsheet was capable of calculating the cost of energy based on the time of use. So just with the date and time, the on or off peak was decided based on if it was a summer or winter month, weekday or weekend, and a certain hour of the day. And so then this resulted in an energy cost based on the maximum kilowatt hour usage for that month. And this is a screenshot of the spreadsheet we use. So this red box shows the label identifier for a specific rate structure, which we got from a database. And so if you input the label, the appropriate rate structure would be used to calculate the cost based on the usage. And this allowed us to calculate energy costs for any rate that we wanted to look at. So key takeaways, overall, I really enjoyed learning a lot more about how solar energy is implemented and also how it is priced. I was not fully aware of all of the different rate structures, so it was interesting to look closely at those. And I also enjoyed learning a lot from my mentor because he's very knowledgeable in the area. And if I was curious about any new topics or anything, he was always eager to answer questions. And I also think that the internship helped me realize that I want to continue work in the renewable energy space. So overall, I would say it's a great learning experience, and I'm thankful for the opportunity. Thank you to my mentor, Eric, and also EcoStudio for organizing this.